far. अच्छा, so this one is के वो कह रहे कि हाइड्रोजन पेरोक्साइड जो है वो इट्स अ अभी वो मैं बताता हूँ सुभान, ठीक है, क्योंकि मेन ऑर्गेनिक है इसके बाद, उसके अलावा फिर कुछ ज्यादा नहीं होंगे। तो हाइड्रोजन वैसे तो उसके अलावा हम कर चुके हैं ज्यादातर चीजें, इलेक्ट्रोलिसिस और ये जो मेटल्स वाले टॉपिक थे। तो पहले यहाँ से स्टार्ट कर लेते हैं कि हाइड्रोजन पेरोक्साइड इज अ कलरलेस लिक्विड। तो aqueous solution of hydrogen peroxide reacts with iodide ions और ये पूरा रिएक्शन है, ठीक है। सो these three things are reacting, ठीक है, this thing reacting with this thing और फिर साथ बीच में ये चीज भी रिएक्ट कर रही है। तो एक्सप्लेन व्हाई आयोडाइड, ये तो रिड्यूसिंग एजेंट्स वाला तुमने किया नहीं है। व्हाट कलर चेंज वुड बी ऑब्जर्व्ड इन दिस रिएक्शन। इसमें अगर आयोडीन का कलर, वो जो शीट एक थी जिसके अंदर कलर्स ऑफ कंपाउंड्स वगैरह, तो रिमेंबर आयोडीन aqueous स्टेट में ना इट्स ब्राउन और येलो इन कलर, ठीक है। वो जो एक शीट मैंने दी थी जिसके अंदर ऑल द टेस्ट ऑफ आयंस और कलर्स वगैरह वो सारा था, तो यू कैन लुक एट द शीट, उसके अंदर कलर्स आर गिवन, ठीक है, आयोडीन aqueous। तो सॉल्यूशन टर्न्स yellowish brown. So anyways, that's not related to rate of reaction. अब अगला जो part है, the table shows how the speed of this reaction changes when different concentrations of different concentration दोनों की use कर रहा है। तो rate of reaction दिया हुआ है, and he's saying use the information in the table to describe how increasing the concentration of the following reagents affects the speed of the reaction. So concentration, remember, is a factor. Rate पांच चीजों पे depend करता है. One of them is temperature, the other one is concentration. You've got pressure, surface area, and catalyst. So either what he's doing is changing concentration. So यहाँ पे वो potassium iodide है, Ki, that was one of the reactant, और यहाँ पे it's sulfuric acid, which has H+1 ions. तो basically इन दो चीजों की ना concentration, he is changing it, and he's trying to figure out how the rate of the reaction changes. So in the first two experiments, if you compare the first two experiments, you would realize the relationship. If you double the concentration of I-1, the rate also doubles. So you figure out that the rate is directly proportional to the concentration of Ki. If you change the concentration of Ki, you double it, the rate over here also doubles. So double Ki concentration, and the rate would also double. ठीक है, तो experiment number 1 and experiment number 2, also you can figure out this relationship. That means that's a relationship that is directly proportional. Okay, both of them are directly proportional to each other. अच्छा, फिर sulfuric acid का करना है. अच्छा, now you have to look for an experiment. If you're looking for Ki, so only Ki should change. The other reactant, it should remain constant, so that I mean, that's the only variable you're changing. Remember, this is a basic law of experiments. Okay, when you're trying to experiment or investigate something, you change only that. Okay, इस चीज को change करने से क्या फर्क पड़ता है, ठीक है? All other variables should remain constant. So whenever you're investigating something, okay, how would the rate of the reaction change with respect to Ki? So only Ki should change, and you'll figure out how the rate of the reaction is going to change. The other reactants, they should all be constant. All other variables should be constant. So if I want to figure out, okay, how is the rate affected by the concentration of sulfuric acid? So which two experiments should I compare? कौन सा होगा? Any idea, anyone? जुबानी पहला क्लियर है? Saneem, any idea? Okay, if I want to figure out, how does the rate change with respect to sulfuric acid? Like how is it dependent on sulfuric acid? So which experiments should I compare? I mean, I'm not going to compare the first two experiments because in the first two experiments, you're not changing sulfuric acid at all. So that kind of remains constant. If I'm investigating sulfuric acid, then only sulfuric acid should change. So the best experiments are probably going to be experiment number 1 and experiment number 3. Like if you compare the two experiments, then you're not doing anything to the concentration of Ki. Okay, so that means that's not a variable. The only thing that's happening is that the concentration of sulfuric acid, it is doubled. It becomes doubled. It becomes twice the amount. What happens to the rate of the reaction? Nothing happens to it. Okay, I mean, there's absolutely no change. So that indicates that, I mean, the rate of the reaction, the speed of the reaction is not dependent on the concentration of sulfuric acid. I mean, you change the concentration of sulfuric acid, nothing happens to the speed of the reaction whatsoever. Nothing happens to it. तो इसके बाद आप लिखोगे कि if you compare experiments 1 and 3, and if you change the H2SO4 concentration, there is no change in the rate of the reaction. Okay, so there's absolutely no change in the rate of reaction. So that means the rate has nothing to do with the sulfuric acid concentration. So is this clear? This one? Yes or no? Is this clear?
Yes, sir.
अच्छा, फिर अगले part में he's saying explain in terms of collisions between reacting particles by decreasing the temperature, decrease the speed of reaction. So when you decrease temperature, what did you study? That the kinetic energy decreases. So whenever you decrease temperature, the kinetic energy decreases. And when that decreases, there would be fewer collisions. I mean, they won't be traveling that fast. So less frequent collisions would happen. And also, what you're going to have is less frequent collisions and less effective collisions as well. They're not going to be that energetic. So the collisions are not going to be that forceful as well. So less effective collisions are going to take place. That's it. Okay, that's just for 2 marks. And then he's saying a student measures the volume of hydrogen gas produced over time, and small pieces of zinc are reacted with sulfuric acid. So zinc is a metal is reacting with sulfuric acid, so it's going to produce a salt, which is going to be ZnSO4 plus H2 gas would be given off. So this is the reaction. At the start, the H2 gas is produced at a very fast rate. Then the amount of H2 gas slows down, and then it becomes constant. When it becomes constant, that means the reaction at this point has stopped. So the reaction at this point has completely stopped. So use the information from the graph to calculate the average speed of the reaction in the first 2 minutes. So first 2 minutes speed, remember, is the gradient of this graph. I did tell you about this, that whenever you measure, whenever you have any graph with respect to time, any change plotted with respect to time, the gradient of the graph indicates the speed of the reaction. So he's saying first 2 minutes. So first 2 minutes would be, in the first 2 minutes, what's the change in y? Change in y divided by change in x. So that I think is I guess 25. So it's 25 cm cube of, so it's y over x, y2 minus y1, x2 minus x1. Okay, so it's change in y, or I can write delta y over delta x. So 25 cm cube of hydrogen gas is produced in how many seconds? In how many minutes? In 2 minutes. So that means the speed is 12.5 cm cube per minute. If you divide 25 by 2, that's what you're going to get. So remember this, whenever you plot, and this could be any change, anything that is changing can be plotted with respect to time. If the change stops happening, that means the reaction has stopped. If the gradient is very steep, that means it's a fast reaction. So the gradient of the graph is the rate of the reaction. Is this clear as well?
Yes, sir.
Clear? What size is clear, Hamza? Saad, is this clear?
Yes, sir.
So explain why the reaction stopped after 6 minutes. So, I mean, it did stop. I mean, at 6 minutes, around 6 minutes, it did stop, right? So why did the reaction stop? I mean, there's probably just one reason why the reaction stopped, that the reactants got used up. Okay, but you have to be very specific. Which of the reactant got used up? He's saying small pieces of zinc were added with excess sulfuric acid. So sulfuric acid was in excess. So excess का मतलब है कि it was more than the required amount. I mean, you added too much of it. So that's not going to get used up. Zinc is the one that's going to get used up. So the reaction would stop because you have run out of your reactant, specifically zinc. Because sulfuric acid is it's already added in excess. ठीक है, अब ये इसके एंड पे ना वो इसी से रिलेटेड था. I'll check, ठीक है. As I explained why the reaction stopped after 6 minutes, zinc got used up. So your zinc got used up, and I said then he's saying copper catalyzes this reaction. On the axis, sketch a line to show how you expect. So now you've added a catalyst. You've added a catalyst. What does a catalyst do? It speeds up the reaction. So if a catalyst is added, the reaction would get speeded up. So what would the graph look like? It's going to be even more steep. So it's going to look something like this, a steeper graph. The H2 gas is produced at a much faster rate. As I just hold on 1 minute, I'll be back in 1 minute. Sorry. I just remember कि steeper graph shoga na, that's a faster reaction, okay? Is this clear?
Yes, sir.
और मतलब अगर वो क्वेश्चन में कहता ना कि रिएक्शन स्लो हो गया तो उसका मतलब होता है कि ग्राफ वुड हैव बीन एंड में उतना ही बनना था, द प्रोडक्ट वुड हैव बीन द सेम, ठीक है, except it would have been a lot slower, ठीक है, it's going to take a longer time, ठीक है, तो ग्राफ जो है वो फिर आगे तक जा रहा होता. So this would indicate कि एक slow reaction हो रहा है. So you were adding a catalyst. Explain how a catalyst changes the speed of reaction. ये हमने वो सारा पढ़ा था कि उसी के अंदर लिखा हुआ था कि ये जिसके नोट्स हैं, ठीक है, वो भी is it opening? So खुल जाएंगे. इधर बता दें. What does a catalyst do? It increases, it reduces activation energy. And when it reduces activation energy, you get more effective collisions. ठीक है? यानी collisions का जो successfulness है ना, you get more successful collisions. So this is what we studied when we were talking about catalyst के ये surface area था. तो catalyst के अंदर we had studied के मैंने वो सारा explain किया था कि it lowers the activation energy and I explained to you यहाँ पे कि what a catalyst does is when a reaction happens, you need, for example, this H2 molecule and this Cl2 molecule are flying in and they're trying to collide with each other. ठीक है, यहाँ से the Cl2 molecule is coming in. बीच में जाके they're going to bump into each other. तो वो इतनी forceful होनी चाहिए that the old bonds are broken. ठीक है, the old bonds need to be broken. Only then can new bonds can be formed. So the thing is that you need some minimum energy. The collisions have to be forceful enough. Okay? For example, if you're trying to break a piece of wood, you would have to strike it with some force. Like if you just strike it very, very lightly, if you just bump into it just very slightly, the piece of wood is not going to get broken. Okay? The old bonds need to be broken. And only then can new bonds or the atoms can rearrange themselves and form new bonds. So some minimum energy is needed. That's the activation energy. So energy is needed to break those old bonds. They need to hit each other with enough force. The collisions have to be forceful enough. They have to be energetic enough. They have to be effective. Because old bonds need to be broken. So I told you that what a catalyst does is it makes it easier to break the old bonds. Taki, you don't need that much energy. So the collisions become more successful. So that is what a catalyst does. It reduces. And I did explain to you that, for example, some molecules have very strong bonds. So even if they collide, they don't react because the old bond or breaking the old bond is very difficult. So, so you need to give it a lot of energy. The activation energy would be very high. So if you add a catalyst, it would somehow make it easier to break those old bonds. So this is what the catalyst does: is it increases, it makes your collisions more effective. As I explained using ideas about colliding particles, what happens to the speed of the reaction when larger particles of zinc are used? So when you use larger particles, lumps, large pieces of zinc, like this, the inner particles cannot react. Only the outer surface would be able to react with whatever thing it's trying to react with. Let's say these are the particles that are trying to react with it. So using large pieces would slow down the reaction because they have lesser surface area. So large particles have they've got lower surface area. And because they've got lower surface area, you get less frequent collisions. क्योंकि अंदर वाले जो particles है वो तो react नहीं कर सकते, so you get less frequent collisions. To explain using ideas about colliding particles, what happens to the speed of the reaction when the temperature of the reaction mixture is increased. So when you increase temperature, you get more kinetic energy. So not only would they bump into each other more frequently, so you get more frequent collisions. But the collisions are going to be more energetic as well, and they're going to be more forceful as well. So you get more successful or more effective collisions as well. तो ये तीनों points आप इसमें mention करोगे कि kinetic energy ज़्यादा होगी है, so the frequency and the effectiveness of the collisions both increase. Here's another graph. Now he's kind of the same. He's trying to plot the volume of carbon dioxide that he's getting with respect to time. So shuru mein the reaction is very fast, then it slows down, and it stops exactly at this point. So he's saying how many, and after how many seconds did the reaction stop? So you can look or mark this point. That is where the reaction has stopped, and you can then measure the time. I think it's exactly in the middle, I guess. You can look 225 seconds probably. So that's when the reaction has stopped. So calculate the number of moles of carbon dioxide released during the reaction. So it's a moles question as well. So what is the volume of gas that's produced? I mean, you can, what's the total volume of gas that's produced at the end? So I think that's 90 cm cube. ठीक है, end में जाके it started with 0, but it kept on at 225 seconds. It got to 90 cm cube. So you can find moles. What's the formula of moles? It's volume of gas divided by 24 dm cube. So it's going to be 90 cm cube, 90 divided by 1000. So it would be 90 over 24,000. And इसका calculate कर लो क्या आ रहा है. ठीक है, you can find the moles. What do you get for this? 9 divided by 2400. So one moles के formulas है ना, moles के there are 4 formulas for moles. ठीक है, one of them is moles equal to mass divided by AR and MR. Second one is moles is like a solution, or that's concentration times volume. And the third one is for gases. Okay, if you've got volume of a gas, you divide by 24 dm cube. So you get the moles. Or एक और moles का, which is okay, if you have number of particles, and you divide by the Avogadro's constant. Which is 6.02 times 10 power 23. Anyway, so we're using this one. Okay, volume of gas. 1 mole of gas occupies 24 dm cube. I mean, 2 moles of gas would occupy 48 dm cube, 3, and so on. So he was asking us to calculate the moles of the gas. The volume of gas pata thi 90 cm cube. You divide by 24 dm cube. And the cm cube has to be converted into dm cube, so you divide by 1000. So वो नीचे जाके multiply हो जाता है 24 से, so it's going to be 24,000. ठीक है, उससे दिया would be 1 mole of gas at RTP is 24 dm cube. So you're going to get 9 divided by 2400. And it gives you 0.00375, 0.00375 moles. ठीक है, that is what you're going to get. फिर एक student repeated the experiment using the same mass of calcium carbonate and the same concentration of acid at 20. पहला उसने किस temperature पे किया था? सब कुछ same है. Everything is the same. The first reaction was at 20, so the temperature is the same as well. So the same mass is used, everything, but this time the student uses smaller pieces. Smaller pieces means it's going to be either powdered. I mean, so if it's powdered or so on the grid opposite, so it's going to be a faster reaction. Everything is the same. Smaller pieces would result in a faster reaction. So he's saying, sketch the graph of that. So the graph would be exactly the same, except with smaller pieces, with powdered, the reaction is going to be a lot faster. Okay, so this is what you're going to get for smaller pieces, a steeper graph. Okay, smaller pieces wala. Is this clear as well?
Yes, sir.
Yes, sir.
अच्छा, फिर ये कि when the student repeated the experiment using hydrochloric acid of concentration 2 mole per dm cube, the speed of the reaction increased. So use kinetic. So what happens when you use a higher concentration? Now he's doubled the concentration of hydrochloric acid. So what happens when you double the concentration is that when you increase the concentration, you get more particles per unit volume. Okay? So that means there would be a lot more frequent collisions. Okay? They would be very close together. So they'll bump into each other a lot more. So you've got more particles per unit volume if you use a higher concentration. and they would be more crowded together, so you're going to get more frequent collisions. So you're going to get more frequent collisions in this case. अच्छा अगला नेक्स्ट एक सेकेंड. अच्छा ये वर्कशीट तो खत्म हो गया, अब वो इक्विलिब्रियम वाली कर लेते हैं. कोई क्वेश्चन तो नहीं है? जस्ट रिमेंबर कि it's all written over here. जो भी आंसर्स वगैरह everything is over here in the notes over here. ये समझा, ठीक है. अच्छा इसमें we can do the equilibrium worksheet now कि equilibrium में क्या क्या है. हाँ जी. अच्छा just one second. Equilibrium is with.
Sir, when are we starting the energy questions?
वो कर लेते हैं, इसके बाद कर लेते हैं ये chemical equilibrium. Just a second. अच्छा this one it's all about equilibrium. We did all of this, ठीक है, everything. तो उसने कहा कि explain ammonia is manufactured by the Haber process. We did that, ठीक है. We did these conditions as well. We wrote these down. So say the economics of this process require that as much ammonia as possible is made as quickly as possible. So the conditions are following. So you have to justify these conditions. Okay, why do you explain how this can be done using the following information? So you have to justify these conditions. So remember, he's told us now this is an equilibrium reaction. Okay, it's and he's given us all the information that is needed for this. So he's told us that the reaction is exothermic in the forward direction. So it is exo, and the backward is endo. So the first thing is, why don't you use a higher temperature? The problem with using a higher temperature is, I mean, there are two reasons. One is good and the other one is bad. TK, we wrote this down in our notes as well. So higher temperature, you get a faster reaction. TK, so that's a good thing. So you get a faster reaction. So मतलब वो उससे कहा था quickly, ठीक है. So it's going to be quick at higher temperatures. So you get a faster reaction. The only problem is that higher temperature favors the endothermic reaction, which in this case is the backward. So, but the problem is higher temperature, according to the Lee-Shatler principle, according to equilibrium, a higher temperature favors endothermic reaction, which in this case is the backward reaction. So that's not a good thing. Okay, yield would decrease. The output would decrease. Okay, you won't get a lot of ammonia this way. So then what's the problem with a lower temperature? The problem with the lower temperature is, I mean, we just wrote it down. Okay, if you lower the temperature, you get more ammonia. I mean, the good thing is, okay, let's write down the good thing first. You get forward reaction, more forward reaction, because exothermic is going to be favored. So exo or forward reaction would be favored. Okay, that's the rule of Lee-Shatler principle. Higher temperature favors endothermic, lower temperature favors exothermic. So forward reaction is favored, and exactly. Okay, you have to look at the question because reactions could be endo, reactions could be exo. Okay, so every time you have to check kaun sa forward hai endo ya kaun sa endo hai. Okay, so lower temperature exo which is forward reaction is favored, which is a good thing. And if forward reaction is favored, एक second. So that's a good thing. You get more ammonia, higher yield. लेकिन मसला ये है कि lower temperature करोगे तो reaction would slow down. So, but the reaction slows down. So that's the justification of using 450 K. You can't use a very high temperature. You can't use a very low temperature. फिर उसका सारा explain करना है कि pressure का. What's good about increasing pressure? Everything is kind of good about increasing pressure. I mean, 1000 atmospheres per layer, it's good. Increasing pressure, I mean, it should be done because higher pressure, faster reaction. You're compressing it, particles would be closer to each other, more frequent collisions, you get a faster reaction. Plus, equilibrium के point of view, it's also good because higher pressure favors the less gas mole side. Which in this case is the forward, because forward means that there's less gas being formed. But a backward jata, you've got you've got more molecules of gas in the backward direction. So that's also a good thing. You'll get more ammonia, less gas mole side favored, more NH3 formed. So that's also a good thing. But what's bad about using a higher pressure? मतलब क्या मसला क्या है इसके साथ? मतलब everything is good. You get faster reaction and you also get more ammonia. मतलब equilibrium के point of view से भी सही है. So ठीक है, it's going to be expensive, it's costly, ठीक है. So but it's costly क्योंकि high और expensive और dangerous भी होता है. Higher pressure के ऊपर you have maintaining a very high pressure is dangerous as well. Safety का issue आ जाएगा, ठीक है. Lots of issues, so cost would go up. Plus वो catalyst का तो वैसे ही फायदेमंद है कि catalyst का आप बता दो कि catalyst की क्या वजह के catalyst, what does it do? It speeds up the reaction at a lower temperature. At a much lower temperature. So that is what a catalyst does. और फिर उससे अगले वाला एक कर लेते हैं कि ये हमने बिल्कुल एग्जैक्ट इस तरह जस्टिफिकेशन उसके अंदर हमने नोट्स के अंदर लिखी हुई है, ठीक है. यू गेट एग्जैक्टली द सेम टाइप ऑफ क्वेश्चंस, ठीक है. जस्ट रीड अप ऑन द नोट्स जो यहाँ पे हमने लिखा था, एंड में बिल्कुल किया था हेबर प्रोसेस, जिसमें हमने उसकी भी जस्टिफाइंग कंडीशंस की थी कि हाउ डू यू जस्टिफाई द कंडीशंस के ये सारा, ठीक है. तो ये हमने दोनों की ना, वी डिड द जस्टिफिकेशन ऑफ कंडीशंस फॉर बोथ ऑफ देम. एक और कर लेते हैं कि the rate of the reaction can be increased either by using a catalyst or by increasing the temperature. And again, he's saying that it's an exothermic reaction, ठीक है. तो उससे कहा हुआ है कि reaction it's an exothermic reaction. हमेशा वो forward की बात कर रहे होते हैं, ठीक है. तो the backward is going to be, I mean it's written over here, ठीक है, it's exothermic. तो the backward would be endothermic. तो वो कह रहे हैं कि catalyst speed up करना है reaction. वो कह रहे हैं catalyst is better compared to a higher temperature. मतलब both of them would speed up. Higher temperature का मसला ये है कि it will speed up, so that's a good thing. कि more kinetic energy. Equilibrium के point of view से बुरा है क्योंकि higher temperature favors the endothermic. So आपका ना backward reaction would be favored. Less SO3, मतलब backward जा रहा है reaction, so there's going to be less SO3 formed. So why not use a higher temperature? That's why. Okay, it will speed up, but the problem is कि वो backward को favor करना शुरू कर देगा, and you're going to get relatively more backward reaction. तो SO2 ज्यादा बन जाएगा, SO3 कम बनेगा. तो so why is a catalyst used in preference? Because catalyst जो है, it doesn't it speeds up the reaction, लेकिन वो उसका ली-शैटलर प्रिंसिपल में कोई काम नहीं होता. Okay, it speeds up both reactions equally, so the equilibrium position is unchanged. Yeah, it does not affect equilibrium. Remember, equilibrium affect hota tha concentration se, pressure se, or temperature se, not a catalyst. So equilibrium remains unchanged. ठीक है, इज दिस क्लियर? ये क्लियर है सारों को?
Yes, sir.
Yes, sir.
चलो ठीक है, हमजा फिर वो एनर्जेटिक्स वाला ना वो हम कर लेंगे, और मैं आपको क्वेश्चन का आंसर करता हूँ, ठीक है? अभी चले, ओके एवरीवन,
That
टेक
is,
केयर,
sir.
अल्लाह हाफिज।